Hello, my name is Daniel. I'm doing my screencast video for assignment number 3. Hope you're doing well. Do my best here to do my best. Okay, so in this assignment, we will create a screencast video explaining the method of solving second order linear homogeneous differential equations with constant coefficients. Excuse me. So first, I'm going to start explaining the general form of the equation, which is seen here. The general form is the PT y double prime plus QT y prime plus RT y is equal to GT. That's the general form. And in order for this to be a homogeneous equation, the GT will have to be equal to 0. Now, to explain the terms that are bold here, the second order just lets us know the highest derivative, which is this double prime here. So that's the second order. The linear just tells us the format of these first ones, letting us know that all these P, Q, and T are all functions of y here, or P, functions of T, excuse me. The homogeneous, again, is that GT is equal to 0. The differential equation is just the equation with functions with derivatives. And the constant coefficients are our R and Q values, which are constants, and coefficients of these functions. All right, moving on to this next part, we're going to explain the solution method. Specifically, we're going to talk about how do we go from a differential equation to a quadratic equation, which is seen here. So we know that y is equal to the exponent of RT y prime, then it would be RE RT, and then y double prime would be R squared E RT. So if you multiply that through with this equation, you substitute that in for A, B, and R, you can simplify that into A, R squared plus BR plus C is equal to 0. So after that, you end up finding that these are, so that you end up getting 3 different general solutions to the problem. So based on the roots, so it turns out if you end up doing the quadratic equation, and if you're in that term, the b minus the square root of b squared minus 4ac over 2a, but if you do the b squared minus 4ac, if it's greater than 0, that means you're going to have 2 distinct roots, and so this is going to be the formula for the general solution for your y value. Now, if your b squared minus 4ac is equal to 0, then you're going to have exactly 1 real root, and this is going to be a general solution. And lastly, if your b squared minus 4ac is less than 0, you'll have a complex root, and your general solution will be this. This breaks down what I was speaking on earlier about the different y values, and this is the equation of the quadratic, or this is the b squared minus 4ac. So now for each case, I'm going to go ahead and just give you a crystal clear explanation, incorporating the simplest. This is the simplest one I can conceive on my own. Excuse me. Hope I don't leave points. This was the simplest I could come up with. Excuse me. So this first one was going to be an example of the first one I have up here, which is going to be greater than 0. So it's 4y squared minus 6y plus 2y was 0 with these final values. So I always break it down to the y squared. Well, m is equal to y prime. So then you got 4m squared. You factor that, you end up with m values is 3 over 2, and m is equal to minus 1. You got 2 m values. So since you got 2 m values, you end up with, you start with this equation like seen above, as for when you got 2 distinct roots. So you start with that equation. Since you have your y0 values, you go ahead and substitute that in and solve. And then you get the prime of this function here, and then you use both of those functions to get values for C1 and C2. Once you have your C values, you go ahead and fill both of those in, your C values along with your M values, and that'll give you the full function here, which is the answer to that first one. That's the solution. For the second one, we did, this will be for the second formula up here, when it's equal to 0, where you only have 1 real root. So on this one, excuse me, On this one, we got 2y squared, 2y double prime plus 4y prime plus 2y. But these are our initial values, y 0 equals 2, and y prime 0 equals 1. So on this one, 2m squared plus 4m, because you know these are our y's, plus 2 equals 0. Go ahead and factor that out. We end up with 2m plus 2 and m plus 1. Obviously, it's going to give us m values of positive 1 and negative 1. We go ahead and use that plus our initial to go ahead and, so this will end up being our yt once we plug in our m value, c1 e to the minus t plus t times c2 e to the minus t, which is what we got from our formula for our 1 roots. Since they're the same root, it's just 1 root, obviously. Okay, and then you go ahead, so y0 is just going to be equal to c1, which will be the 2 value that we got initially, because when it cancels out, c1 is the only thing remaining. Now that you got c1 in the roots, it will be nothing to go ahead and solve the y prime of t, which will give us this problem. You go ahead and factor that down. You end up with minus 2 plus c2 is equal to 1. A simple math, add that 2 over. Now you got c2 is equal to 3. So now we plug that into our formula. Now we got 2e to the minus t plus 3t to the e to the minus t. That'll give us our answer solution to that one. Now going to this last formula, which was the harder one for me to make. I hope it's not too complex. It was kind of hard to make one for me. But it's when it's the b squared minus 4ac is less than 0. You get the complex root. So when you have a complex root, you already know your a and c values are going to be quite large. So we got 12y prime, double prime, plus 10y prime, plus 8y is equal to 0. These are our initial conditions. So we know that, so we take that down to 12m squared, plus 10m plus 8 equals 0. When you do the quadratic equation with this one, you end up getting m is equal to minus 10 over 24 plus the square root of 384 over 24. Kind of crazy. Hope it's okay. So doing the same thing we did, we go ahead and plug those into our formula for these complex, which is this one here. So we go ahead and plug that in, and we end up getting yt is equal to e to the 10 over 24t times a. This is minus 10 right here, by the way. Times a, excuse me, cosine of this plus b cosine here. So y of 0, everything is going to have a 0 in it. So it ends up just being 0. I mean, it ends up going to 8. This is going to be 1. This is going to be 0. This is going to be 1. So it's just a plus 0. So so it's going to be equal to our initial condition of 0. So we got the value of a. Good. We go ahead and get the derivative of this one, which will ends up being quite a long one. You see it here. I'm not going to read that all out. I think you'll thank me. Okay. But then, since we know our value of a, this cancels out. Sine of 0 is 0. That cancels out. The a makes this one cancel out. And the last term we have is this one, only one that stays, which is the square root of 384 over 24 times the cosine of 0 is 1. So it's just b here. So now we know that the square root of 384 over 24 times b is equal to the initial y prime value, which is 1. So now we just have 1 is equal to that. Take the inverse of that. You'll have 24 over that. That'll give you our b value. We have our a and our b and our m values. So we go ahead and plug that in here. And then we get, this will give you our solution. And that is all 3 of the major cases you could have there. Now, once again, thank you for watching my video. I hope I did pretty good. I hope my problems weren't too complex. I hope you have a good rest of your day, rest of your week, your life. I appreciate your time. Thank you.